any given string has some type of indexing associated with it. Generally speaking, the indexing starts from whatever the index of the first character of that string is, and then it's incremented by a delta value to go to the next, and perhaps a different delta value to go to the next character. So generally speaking, the increment is not fixed and it's not equal to 1. The reason for that is that some characters may need larger amount of memory, and as a result the indexing will not be uniform. But for many familiar characters, the indexing is actually equal to 1, and it could be assumed to be equal to 1. But it is important to remember that in general that is not the case. So in Swift, we need to have a point of reference when we're using indexing. One point of reference would be the index of the first character, and the way that can be actually generated is using this structure. So we have x, which is the name of a string, followed by dot start index. This is another keyword. So this will generate the index of the first character of our string called x, and that is returned in this particular example to y. In this particular case, the index which signifies the position of a here is 0. There is another keyword called end index, which we can use to point to the character which would come after the last character of our string. So in this particular case, whatever index is generated here is not pointing at C, it's pointing to the character which comes after. So in the case of this example, when incrementing is 1, A is equal to 0, B is 1, and C is 2, and the one after that would have an index of 3, and this is what we get out of end index, which is the value which is extracted and assigned to Z. One important thing to remember is that in the case of empty strings, start index and end index will both generate a value, the same value, and in this particular example we would be having the same value of 0. So they are equal. Through indexing, we can access different parts of a string. We're using different offsets, or we can just using unity offsets. This is shown here with some examples. We are having a variable called x, which is of type string, is equal to abc. We generate its starting index, which is 0 in this case, assigning it to y. Ending index is generated using this arrangement. We're assigning it to z, which is equal to 3. Now we define idx. It's a variable, and we assign it the value of y, which was 0. Now, if we wished to extract the first character of this string, we could use this arrangement, x, which is the name of the string, followed by square brackets. Inside the square brackets, we put the index of the character, the first character of the string, which is 0. So we could have said x, square brackets, 0, or because idx is already equal to the index of a, we could just insert it in here, and this arrangement will generate the character corresponding to this index. So A is the result of this. Now, if we already have an index, in this case y, which is the start index, we could use this arrangement. X, which is the name of our string, ABC, followed by dot index, this is a keyword, parentheses, and inside parentheses we use the keyword after, followed by colon, and y here is our reference index, in this case 0. So what this one is saying is we'd like to generate the index of the character of x which comes after index y. Y is 0. The one which comes after it will be 1. So this will generate 1 and assign it to idx. Then when you use this arrangement here, we are extracting the character of x corresponding to index 1, which is b. And this is the result. Now, instead of after, we could use the keyword before. It works exactly in the same way. But then, of course, if you start with A, or the start index, and we want to refer to the, if you use before, we'll be referring to the character before this, which is not of interest to us. So we have to start with an index which has other characters within the string which are of value to us. So in this case, I'm starting with Z. Z is the end index, so we are pointing at the character after C, that would come after C. And then this arrangement is saying, okay, whatever that index is, which is 3, Z is equal to 3, we go one before. So we are looking at index 2. So that 2 is generated and passed on to idx. And then using x square brackets idx, we are trying to extract the character of x which corresponds to index 2, and that would be C, because if you remember, the indices of these were 0, 1, 2, so 2 corresponds to C. Now these are the cases when we are starting with the reference point and incrementing or decrementing by step of 1. If we wanted to increase the step or use a variable step size, we could use this arrangement. Again, x dot index remained the same. We have parentheses. Inside the parentheses, we have the point of reference. In this particular case is y, which is the start index. And then we use the keyword offset by, followed by colon, and then how much we want to offset this reference index. In this case is 1. So we start with index y, which is 0, and we offset it by +1. So we go to index 1, and that index is generated by this and passed on to idx. Then idx is used this arrangement to extract character b. Of course, the indices were 0, 1, 2, and index 1 here will refer to b, and b is generated. Offset by could be negative. So if we started with in this case z, which is the end index, and offset it by -2, z is 3, offset by -2, 3 minus 2 is 1. 1 is generated here and passed on to idx, and again b is extracted. In an example earlier on, we saw how we could extract individual characters of a string using a for loop, but that arrangement did not use the indexing, string indexing. Here we can do that. So again, using a so-called for in loop, because we have the name for and in inside here. IDX is a temporary parameter. We use this arrangement, x.characters.indices. Again, all these in yellow are keywords. So this will generate the indices of all the characters within the string called x, and then all those indices are allocated to IDX on a one-by-one basis. And as long as there is an index left here, the loop is repeated. And in this particular case, we're going to print this string, where backslash is used as before when we are trying to print a variable or constant, square brackets, and then x idx, which is the same as this. So this is going to extract the character of x whose index is idx, and that idx, the index idx, is extracted from this structure. Backslash n will generate a line break. So as a result of this, we will print the individual characters of this string followed by a line break. So one character, line break, and the next line we have the second character, line break, and so forth. We could modify strings in Swift. We could insert a single or a series of characters within a string. To insert a single character within a given string, we can use dot insert. Insert is again a keyword. And for this, here we have an example of x again is equal to abc as previous examples. Then we're generating the end index of this and assigning it to a variable called y. Then this is the arrangement that we can use to insert a character within the existing string. So the format of this is the name of our string variable x dot insert keyword parentheses. Inside parentheses, as the first argument, we have the character we want to insert inside this string, comma, keyword at followed by colon, and y is the position that we want to insert this character. So end index will be pointing at the character after C. So as a result of this, x will be modified and will become equal to ABC as it was before, but D will be inserted at this position, which is the end position. So we will get A, B, C, D, and this is the new value of x. So that's how x is modified. Using dot insert, we could also insert a string within another string, as I just mentioned earlier. So here we have two strings, x1, x2, and again I'm generating the start index of x1 in this case and assigning it to y. Now this is the arrangement that we can use to insert a string inside another string. So x1 is the string that we want to modify, ABC, followed by dot insert a keyword again, and parentheses. Within the parentheses, we are going to have another keyword, contents of, followed by colon. So this is the contents of the string which appears after this. So x2.characters are actually the characters of string x2, which are used as the first argument of insert. So contents of, and these would be the characters of the string that we want to insert into the first string, followed by comma, at, which is a keyword, colon. This thing is giving us where in the initial string we want to insert these characters. So in this particular example, we are using the same arrangements that we discussed earlier on to generate an index. So it's x1.index, y is the start point, it's offset by 1. So we are going to start with the index of b, which is because y is 0, offset by 1 is 1. So index b will be corresponds to b. So we want to set to insert these characters, which are t and u, at the position of b. So this would be the result. So as a result of this, x1 is modified, and the modification is the insertion of the characters of x2 as at position 1, which is the position of b. So we will have a, and tu will go here in that position, and bc will be pushed to the right. So this would be the outcome. The same way as adding a character or a string to a string, we could actually remove a character or a string from a string. So to remove, we use the keyword remove, and in order to remove a single character from a string, we do as follows. Let's consider this example. Again, these are familiar. X is a variable equal to ABC, and y is the start index of this. We set idx, a new variable, to be equal to the start index y, and then we calculate another index using y as reference here to generate the index to be equal to whatever y is and offset that by 1, so the value of idx will be equal to 1. As a matter of fact, it is not necessary to do this assignment. We could just omit this assignment here. So we could declare idx here and set it to this value, which is equal to 1. And now we have the index that we want to use to remove the character from our string. So ABC here is our string. The index was evaluated to be equal to 1. So using this arrangement, x, which is the name of our string variable, dot remove, a keyword, parentheses, at again another keyword, colon, and we use the index that we evaluated before, which is 1. So what this thing is saying is that we take x and remove the character which sits at the position pointed at by index idx, which is equal to 1. And in this case, we're talking about b. So as a result of this operation, b is removed, and what is returned is ac. Finally, we can remove a string from, or let's call it a substring, from a longer string. The way to do that is to use the keyword dot remove subrange. Again, these are just the familiar variables that we have declared in the previous example. Again, y here, assignment of y to idx is not necessary. So here we calculate the value of index that we want to use, and this would be the position within our string that we want to, from which we want to remove some characters, right? So again, this is the same as before. So y is 0. In this case, this is a start index offset by 1. So idx will be equal to 1. Now we define a variable called range, which starts from y, which is the starting position, and then goes to idx, which is 1. So the value of range is 0 and 1. Then we use this x, the name of our original string variable, followed by dot remove subrange. This is the keyword that we mentioned before. Within parentheses, we have range as the argument, and as a result, what this does, it removes all the characters which falls within this range, 0 and 1. So a and b will be removed, and the whatever is left behind within x is only c. In Swift, strings can be compared directly, and it's quite straightforward to do so. The result of the comparison would be a Boolean. So an example is shown here. We're using the equal to comparison operator, and we are having two strings, string 1, string 2, and we're comparing them and see whether they're equal or not. If they are, the Boolean true will be returned, and that value is assigned to our variable check, which is also a Boolean. So if these are not equal, these two are not equal, check will turn out to be false. Similarly, we could use the not equal to operator, and the outcome of this would be true if these two are different, and if they are the same, the outcome will be false. Something else that we can do is that if we wish to check whether a given string starts with a particular pattern, we could use the keyword has prefix to check that. So in this case, we have a variable string called s1, which is equal to string 1. Then we use this arrangement where s1 is the name of our string variable, followed by dot has prefix, which is the keyword I mentioned here. Within brackets, we have the pattern that we are after, in this case str, and whatever the return value of this is going to be assigned to check. Now what this returns is that it compares this pattern with the beginning of this string. The reason that the beginning of this is used for comparison is because we're using has prefix, right? And if the pattern is the same as the beginning of the string, this arrangement will return true, otherwise it returns false, and that would be assigned to check. A similar arrangement exists, so instead of has prefix, we can use has suffix to check whether a string ends with a particular pattern. So here again we have another variable called s1 whose value is first string. Now we use this arrangement s1.has suffix, and inside the parentheses the argument is ing, which is a string on its own. So by this we are asking a question whether s1 ends with characters ing. If the answer to that is yes, if it is true, a true is returned and assigned to check, otherwise false will be returned. This was the end of our tutorial on strings and characters in Swift.